laws do not truly exist, according to the argument of theoretical physicist Sankata Sama in a new column published by New Scientist. Sama says that while we define physical laws as the ultimate laws of the universe, they are merely descriptions and mathematical equations corresponding to parts of nature. The new column is part of a special monthly newsletter by New Scientist, which provides insights from leading experts in various fields. This special column is interesting for several reasons, including the fact that a theoretical physicist who is truly dedicated to studying the universe is somehow arguing against the most fundamental physical laws. While many scientists believe physical laws as the absolute and ultimate laws of the universe, Salma says they do not exist and that if we do not regard them as absolute, it would actually be much better for physics research. But how to prove that physical laws do not truly exist? According to Sama, the physical laws we know are just mathematical equations we have created to help define certain parts of nature. After all, the reason we call it theoretical physics is because it is entirely based on theories and equations. When we try to prove that these laws exist, all we are actually doing is clarifying more details about how the universe operates. Think of physical laws as things we believe are good and reasonable ideas about how our universe moves, how galaxies form, how stars die, etc. However, when studying more about the early universe and dying stars with more powerful devices, like unrestrained scanning telescopes, we are gradually discovering more about other parts of the universe. Thus, Salma says it is better to view physical laws as if they are layers of an onion. As we learn more about the physical properties of the universe, we are gradually peeling more layers, but those layers are infinite. There is always more to peel and therefore, always more for us to learn about how the universe operates. It is a fascinating proposal and one you might not expect to come from Tutsun Kadasama, someone who has devoted himself to researching how the universe works. But if he is correct and scientists start viewing physical laws more like layers than absolute rules, we might find new ways to learn about the universe. Discovery of intense shock waves from galaxy collision. Shock waves caused by the chaotic collision in the South Africa cluster are driving strange processes in the intergalactic environment. Located about 270 million light-years from Earth, Saturn's Quintet is a group of colliding galaxies, originally consisting of NGC 731-7, NGC 731-8A, NGC 730 forms a physical link, meaning a group of galaxies that may actually merge in the future. And the intruder NGC 731-8b is heading straight into the center of the group at speeds of up to over 2.9 million kilometers. Approximately 805 kilometers. This chaotic structure is considered an ideal laboratory for studying interactions between galaxies, including violent collision events and how these interactions affect their environment. New observations made with the James Webb Space Telescope and the ALMA ground-based telescope array in Chile have provided astronomers with a clearer view of what happens inside Saturn's Quintet when the intruder NGC 731-8b violently crashes into the quartet of galaxies. This violent collision created large shockwaves many times the size of the Milky Way and propagated through the interstellar plasma, triggering recycling factories of warm and cold molecular hydrogen gas among the galaxies of Saturn's Quintet. Additionally, Webb and ALMA found a giant gas cloud breaking apart to form a foggy layer, warm gas, which could be the result of a collision between two clouds or even the formation of a new galaxy. Lead author of the study Philip Apperton, a senior scientist at the Infrared Analysis and Processing Center of the California Institute of Technology, said when the intruder crashes into the quartet of galaxies, it collides with an old gas stream and creates a giant shockwave. As the shockwave propagates through space, it creates a very chaotic cooling layer and precisely in the areas affected by this intense activity. We are seeing unexpected structures in the process of recycling molecular hydrogen gas. This is important because molecular hydrogen forms the raw material that could eventually form stars.
Understanding its fate will tell us more about the evolution of galaxies and galaxies in general.
The new observations have significant implications for theoretical models of the effects of chaos in the universe. However, scientists still need to study more to understand the impact of high-level chaos as well as the warm and cold hydrogen gases forming the mixture. Although Webb and ALMA data have provided much information about the relationship between warm and cold hydrogen gas mixtures, with hydrogen gas being heated by shockwaves, the research team will have to turn to spectral data for a full understanding.
First discovery of a planet spiraling and then disappearing.
Scientists have just discovered the deadliest planet ever observed in astronomical history. Planet Kepler 1658b is 2,600 light-years from Earth.
According to researcher Shwayas Visapragira from the Harvard-Smithsonian Center for Astrophysics and colleagues, they discovered something strange about Kepler 1658b. It is spiraling in a death spiral instead of a stable orbit.
This anomaly will certainly soon lead to an extremely tragic end, crashing straight into its parent star and then disappearing in a fierce blaze. The tragic death of the planet is estimated to occur in the next 3 million years, a period that seems long to humans, but is just a blink in planetary history. What is happening today is the tragic gravitational interaction that large planets orbiting too close to their parent star may encounter,
in which the too fierce gravitational pull of both will pull them together.
But certainly the one being swallowed will be the planet, which is very small compared to its parent star. Currently, Kepler 1658b orbits its parent star at a distance only 1/8 that of the distance between the Sun and Mercury. Each orbit around its parent star now takes less than 3 days and is shortening by about 131 milliseconds each year. Kepler 1658b is a hot Jupiter, meaning it is a gas giant planet but located very close to its parent star. However, it is very likely that it will soon have its entire atmosphere blown away by the parent star, becoming a small Earth-sized iron mass. Its aging parent star is also in the stage of expanding into a red giant, the final brilliant moment of stars about to exhaust their energy. This causes the planet and the star to move closer together, with the gravitational force between them much.
And this could also explain how this old planet was pulled out of its stable orbit.
This planet could show us our own future, as it is estimated that in 5 billion years, the Sun will enter the red giant stage,
expanding enough to swallow the 3 closest planets, Mercury, Venus, and even Earth.
This causes the planet and the star to move closer together, with the gravitational force between them much.
And this could also explain how this old planet was pulled out of its stable orbit.